Hello friends, in this lecture we will be studying about depth first traversal. Now this is the first and the most basic graph algorithms. Now is depth first traversal and what we do in this? Basically you are given a graph this sort and you have to traverse this graph in a depth first search manner. Now what is a depth first search manner is, you can start with any node. Let's say we basically start with 0. You have to traverse this graph in a depth first search. Means you have to traverse it depth wise. From 0 you go to 1 and from 1 you go to 4. Now 4 you come back to 1, you come back to 0. Now from 0 you go to 2, from 2 you go to 3, you come back from 3, you come back from 2 and you go to 0 again. Now from 0 you can go to 3, but since it is already visited, we won't visit it again. So you have to traverse it in a depth wise. Another example can be, let's say a graph have nodes like this. I'm just taking a random example over here to illustrate a depth first search manner. Let's say we have a complex graph like this and all these are nodes. You can increase the complexity of graph to understand what is basically depth first search. Right. Now what you have to do is you have to traverse it in a depth first search way. Right. Let's say our source node is this. We start the traversal, we go to its neighboring node. There are no neighboring node, we return back. Then we find its neighboring node. From this we go to this node. From this we go to this node, and then this one, then this one, then this one, then this one, then this one. And you can't go to again this node. So you return back, and you return back completely. From here you have no neighboring node, you have no neighboring node, no neighboring node left, no neighboring node left, and you similarly come here. Now you have a neighboring node over here, you have a neighboring node over here. Now you have no neighboring node, you return back and you return back. So this will be your depth first search way. You have to traverse the graph in this way. Now, how will you do that? Before that, the first question is, how are you going to store the graph? Which data structure you will be using to store the graph? Now, what will happen is, the best way to store the graph is to use an ArrayList array, also called an array of ArrayList. So basically for 0, you will store all its neighbors. What are the neighbors of 0? 1, 2, 3. What are the neighbors of 1? 0 and 4. For this graph I am talking about. What are the neighbors of 2? 0 and 3. What are the neighbors of 3? 0 and 2. What are the neighbors of 4? 1. Only 1. So basically this is our array, and for this array, each array element denote an array list, and this array list is the neighboring nodes. Now what you will do is, how you will traverse it. The best way is to use recursion. How will you be using the recursion? You will visit each node. For example, you start with 0. You will traverse all its neighbors, all neighbors of 0, all neighbors of 0, and then for each neighbor you will give, like for 1, you will give a recursion call. For 1 you will give a recursion call, and for 2 and for 3, and this will be doing it in for loop, because you are basically doing a traversal over here. This for loop is nothing but you are basically iterating over 1, 2, 3. You will giving a recursion call over here, and for each recursion call, like for 0 the recursion call is 1. For 1 the recursion call will be for 0 and 4, but since 0 is already visited, we will do it for 4. For 4 the recursion call is 1. 1 is already visited, so we will now return back, and then we will be returning back from 1 as well, because there are no neighbors left over here. Then we will go to 2. For 2 we will be giving a recursion call for 3 since 0 is visited. Then for 3 we can give the recursion call for 2 or 0, but since both are visited, we will return back, and then similar like this the whole traversal will be done for this graph. and what will be the result? What will you be printing is 0, then 1, then 4, then 2, and then 3. You have to print this result. Now one thing which is tricky over here is this is fine. This is the code. But what else? What is there something left? Yes, of course. What is left over here is this is 0. 0 will be giving recursion call for 1. Now we will go to 1. 1 has its neighbor 0. Now 1 can give a recursion call for 0 as well. So you have to tell the code that 0, it is already visited. You don't have to give a call for 0. For this, you can use a hash map. How we'll be using a hash map is, as soon as you visit the node, you will store that it is visited. For 0, you are visited. For 1, you are visited. Then for 4, you are visited. You will be storing this in hash map. And before giving the recursion call, here, you have to just check a statement over here that if it is visited, you don't have to give the code. That's it. This is our simple for loop for depth first traverse. Now I hope it's clear. We will be going to the code right now. Now look, over here we have n is equal to 5. I'm taking the same example. We have the 5 nodes over here. Then we are declaring an array list which has size n, and then we have a for loop declaring the new array list over here, and then we are preparing the array list, the array of array list. 0 has its neighbor 1, so we are adding, for 0 we are adding 1, for 0 we are adding 2, and for 0 we are adding 3. 0 we are already prepared. Then for 1 we are adding 0, for 1 then we are adding 4, because 0 and 4 are the neighbors of 1. Similarly for 2 and 3 and 4. So this is our array list completely prepared. Now this boolean visited. Now what it is boolean visited, hash map integer boolean that is visited. This is our hash map. After declaring the hash map, we are going to call the recursion. What will recursion do is, what are the parameters we are passing is the array. The array is the array list of integer we are talking. The graph. And then we have this n. Now what this n is? The total number of nodes. That is the 5 visited. Now visited right now do not contain any element, but as soon as we traverse it down, we will be adding the elements that are being visited. And for this is our source. The 0 is basically our source. This 0. Source node is equal to 0. You can start your traversal from any node. And then we are going to call the recursion. Now first of all, now what we are doing is, we are doing this current node. We are capturing the 0 in the current node. Now for the current node, we are using its array. We are traversing on this array and we are giving a recursion call. Before giving the recursion call, we are just checking if visited contains key that neighbor. If it is false, then only we will be giving a recursion call, else we won't be. And this is the neighbor. Everything we are passing the same, the array, the n and the visited, but we are passing the neighbor instead of the current node. Also, we have to put the current node in the hash map. So in this statement, we are putting the current node in the visited hash map to tell that the current node is already being visited. And for displaying the output, we are printing the current node over here. So this is our basic recursion call function for DFS. And above is the array of array list we are making. Right. So we'll run the code once. The output is 0, 1, 4, 2 and 3, and this is the desired output we want. 0, 1, 4, 2 and 3, and the output is this one. So I think it's done. Okay. Thank you.